Bismillahirrahmanirrahim. This question is May June 23, variant 41, question number 7, topic electricity. Shows figure 7.1 shows a circuit that contain a battery, a switch, a voltmeter, and three 40 ohm resistors. Three 40 ohm resistors, R1, R2, R3. It means this R is equal to 40 ohm, this is equal to 40 ohm, and this is equal to 40 ohm. R3 resistors are 40 ohm. The switch is open and resistor R1 and R2 form a potential divider. Mean these two R1 and R2, these form a potential divider when the circuit is open. So question is that describe what is meant by a potential divider. Potential divider is actually a circuit. What's the function of the circuit? Uh, so a potential divider is a circuit that split EMF into two components that may be resistors connected in series to the power source. So these two resistors are connected with this power supply in series. So this is a function of potential divider. Part number B, the reading on the voltmeter is 7.5. The reading on the voltmeter is 7.5. Calculate the electromotive force EMF of the battery. Okay, this is a potential divider circuit. So in my last question, last to last question, maybe somewhere I have explained the concept of the potential divider. So I'm explaining again. This formula is very simple. If you forgot to write the formula, then it is very easy that you can make this formula by yourself. Consider this is EMF, right? And this V gives you the V out, output voltage. So how to write a formula? The method of the formula is that you will write that resistor as a numerator across which the voltmeter is connected. So R1 is written as a numerator and both resistors are connected in series. So you add them, add these two resistors R1 plus R2 and then multiply the value that is given as an input. So multiply with E, that will be equal to this V out. So I have the value here as V out. Okay, what's the question? Question is that calculate the EMF of the battery. So we have to find out the EMF of the battery. In this question, it is given that voltmeter reading is 7.5. It means this voltmeter have the value 7.5. So V out is 7.5. All three resistors are 40 ohms. So 40 divided by 40 plus 40 multiplied by E, that is unknown value. Okay, so 7.5 is equal to 40 divided by 80 multiplied by E. So calculation shows that 7.5 is equal to 1 over 2 times E. So E will be equal to 15 volts. So here I will write the answer 15 volt. This calculation you can mention in this place. Okay, due to some reason, I cannot shift this value here on this place. So when you will solve this, you can place these calculation on this place. Anyways, the switch is closed. Okay, this switch is now closed. This switch is now closed. So when this switch is closed, then it means R3 and R2. Now both will be connected with parallel. This is 40 ohm resistor. This is 40 ohm resistor. And question is that calculate the resistance of the complete circuit. So we have to find out the total resistance. So first of all, I need to calculate the combined resistance of these two. And I think you know well that how to find out the combined resistance. So RC, C for combined, I can write R2 and R3. Okay, so R2 multiply by R3 divided by R2 plus divided by R3. All resistors are identical, so 40 multiplied by 40 divided by 40 plus 40. So it will be equal to 1600 divided by 80. So 0 cancel and answer is 20 ohm. So this complete region gives you the value total combined resistance 20 ohm. Okay, so when you will add the 20 ohm with this 40 ohm resistor, then the total resistance of the circuits become RT is equal to 20 combined resistance and 40 in series. So total resistance will be equal to 60 ohm. Last part of this question, calculate the reading on the voltmeter when switch is closed. Okay. So now again, I will deal these two resistors at a combined resistance. So combined resistance I just have calculated, that is equal to 20 ohm. So the new format of the circuit is something like that. This is R1 that is equal to 40. This is a combined resistor RC that is equal to 20, and this resistor is connected with the battery. Okay, so now in this situation, what will be the value of the voltmeter? What will be the value of voltmeter? So this voltmeter, I will use the same formula of the voltmeter. As I told you in the previous part, that formula you can easily write by yourself. The voltmeter that is connected across R1. So you will write R1 as a numerator and R1 and the combined resistance as in a numerator after addition, because both are connected in series. These both are connected in series. Multiply by the V in, that is EMF, and that will be equal to this V out. So I have to find out the value of the voltmeter. So here the V out will be equal to mean output or voltage, voltmeter reading will be equal to 40 divided by 20 plus 40 multiplied by V in, that is equal to 15, because we have found the total EMF value of the circuit, that is 15. So after this calculation, this will be 40 by 60 multiplied by 15, and that will be equal to V output. That will be equal to V output. So calculation is very simple. 15 one time, 15 four time, and for one time 4, 10 time 40. So V out will be equal to 10 volts. So answer will be equal to 10 volts.